Hello everyone, I'm Alfian and today we are going to solve the HackerRank challenge on the data structure section called the getNodeValue. And for this particular challenge, we are using Java 7 as our language of selection. If you want to use something else other than Java 7, then go ahead. I encourage you to do so. Okay, so for this challenge, given a pointer to the head of a linked list and a specific position, determine the data value at that position. Count backwards from the tail node. The tail is at position 0, so its parent is at 1 and so on. And for the example, we have the head parameter refers to the 3, 2, 1, and then chain with the next node of 0, and then the next property is null, and the position from tail is as defined as 2. Each of the data values matches its distance from the tail. The value 2 is at the desired position, so we need to first find the tail of the node, which is 0 right here instead of null, because 0 is the only one that is considered a tail because it has the value of data, and we need to count position from tail, which is 0 and then 1 and then next one 2, and then we have the data property of 2 from the value 2 from the back of the node chain, which is the tail of the head node chain. And for the function description, we have to complete the getNode function in the editor below. The getNode has the following parameters, which have two parameters. The first one, which is the inner form of data type single linked list node called the list, and the second one, which is the integer called the position from tail, and the function itself in a form of static, expecting an integer as the returning value from the getNode function that we need to solve, and the position from tail parameter, which is the item to retrieve position from the tail, which is 1 and 2, and that the value 2 or the answer is that we need to solve this out. And for the return, the value is at the desired position from the position from tail parameter. Okay, so without further ado, let's solve this out by creating a pointer called another singly linked list node of the pointer or the iterator of the linked list, since we cannot use linked list to iterate over the linked list because the linked list is already pointed at the head of the node. Then we need something to iterate over the linked list chain using the current that takes the value from the first parameter of the linked list parameter right here. And for the next one, we need some kind to iterate over the node of the list node, and then after that, with the help of the current node iterator or the current pointer, then as we go along the way, we need to record the data property of every node that we traverse from one to another, and then we need to check if it is already at the end of the node. Then of course we stop our iteration because the null doesn't contain any data, and then we return the data 0, which is the tail of the node. And then after that, we need to traverse back to find our answer from the position from tail based on the number from the position from tail parameter, and then we iterate 0, 1 and 2, which is 2 times from the second parameter right here. Okay, so to solve this out, we need class stack of the Java 7 class of the utility, and we have the stack class, which is the last in first out, level stack of object last in first out, and then we have this declaration of the constructor, and this one is dq of the data type of integer called the stack, and then we construct new array dq and in a form of integer data type, so the stack is only filled with integer instead of other data type like string or floating number or etc. So let's copy this out and then go back to our code, and then this dq, or we can change the dq to stack, in the stack data type of stack integer, and then we construct the, instead of array dq, we need to construct the stack, and then there you have it. We have the stack variable that the sole purpose is to stack over the data value from the tree as we traverse upon using the current node or the iterator. So we need to stack 3 as the data into our stack, and then on top of the 3 we stack 2, on top of 2 we stack 1, and then on top of 1 we stack 0, and then we don't have to insert the null into our stack because it is already null, and the tail is considered the last node, which is 0. And then using the position from tail parameter, we need to pop the stack from 0, and then the next one we pop 1, and then the next one we pop 2 based on the second parameter right here. And then after we pop, at the same time, using the pop method, we return the data from the last in first out cycle. Okay, so for example, we have the, let me use the comment, we have the LIFO structure, we have the first one, we have the stack as we iterate over using the current, iterate over the L list, we have 3, and then we assign 3 as we traverse, and then 2, we assign 2 on top of 3, and then 1 on top of 2, and then we assign 0 on top of 1, and then we don't have to use null because it is already at the tail of the node chain. Then for the first out, last in first out, last in first out means like if we pop using the .pop method, we pop 0, and then we return 0 into our answer, and then we pop 1, and then we pop 2 instead of we pop from the tree because we are using the LIFO structure. So the structure starts from the bottom to up, and then for the first out we start from the top to the bottom until the stack is depleted. Since the position from tail is 2, then we need to pop this 2 times, and then therefore the first one 0, and then the next one which is 1, and then for the return we need to use the pop method, and then we at the same time we return the value from the pop method. And I will show you right after this. As we pop this 0, we pop once, and then 0 will be eliminated, 0 will be returned if it is assigned, if the pop method is assigned as the variable like this using the, let's say we have the integer pop data as example, and it is still outside of our implementation, but for the sake of the tutorial I'm going to show you this. We have the integer data type of the pop data. Since the stack is expecting an integer data type, then of course we use the integer, and then we assign the Stack.pop to return the 0 from the stack, and then we return 0 as our pop data variable using the Stack.pop. If we don't use the integer pop data variable using the Stack.pop, will also remove 0 but not returning 0 into any variable whatsoever. So using the Stack.pop again 2 times, we remove 1 from our stack. Then for the return statement, since it's expecting integer, then of course we can use another Stack.pop to ask our answer. We can simply use the return statement, return from the function, return at the end of the function of the getNode function, then we simply return Stack.pop, and then we return 2 as our answer. Okay, so to iterate over the linked list chain, we need to use the while loop. Using the while, as long as current is not null, then of course we traverse the current to up to the point to the tail node using the stack.add. We have the add method, just like described on the method right here. We can use push and we can use add, but let me use push instead of the add. In the push, which is the element of item, the E right here, which is symbolized the element or the abbreviation of the element, and we have the item right here, which is the variable from the property data from our linked list. We can use the stack.push instead of using the add. If you want to use add, you can do that, but for the sake of this tutorial, I'm going to use push to minimize misunderstanding. Using the stack.push, and then we use the current.data, pass in the current.data property, and then we assign 3 as our stack, and then we can use the current equals current dot next. This way, we are moving the current pointer of the linked list. Since the current equals the L list, then of course the current is pointing to the tree right here. And then you see the current equals current dot next, then we point the current dot next, which is the 2 right here of the node 2. We assign this as our current node pointer. So that is why I'm using the current as our pointer and as our iterator to iterate over the linked list and find the tail of the linked list. And then along the way we assign the current.data into our stack variable. And then after that we got the 3, 2, 1 and 0 from the while loop operation alone. To fulfill the position from tail and to return the 2 as our answer, we can simply use the for loop for integer I equals to 1 as long as I is below or equals to the position from tail. Use the parameter for now, and then you use ei plus. Oops, I wasn't intending to use the square brackets, and we use the curly brackets instead. And this for loop we iterate over the stack, but using the position from tail as our desired data that we need to return based on the position from tail parameter. And then we declare I as 1, and then from the iteration 1 we have the iteration 1. Then we use the Stack.pop without passing any parameter inside this pop method, because pop is not contains the element of the item, unlike the push method. And this removes the object at the top of the stack and returns that object as the value of this function only if it is assigned as the variable, like I already described earlier using the integer of the pop data. Let's go back to our code using the pop, just like that. And then for the first iteration, we pop this one using the I equals 1 and I still below the position from tail, which is 2. Then we need to remove 0 from our stack. And then the next one, I equals to 2, and 2 is still equals to the position from tail, which is also 2, and it is still fulfills the below or equals to position from tail. Then of course the for loop still works using the Stack.pop again, and then we remove 1 from our stack, and then the for loop will stop because the I is already equals to 3. And then since it is 3, then of course the I is already higher than the position from tail, which is 2. And then we can simply return, use the return statement. And for the return, you guess it, using the Stack.pop again. And that way we are returning 2 as our answer, and at the same time popping this from our stack. And we return 2 as our answer. Okay, so let's test this out to see if it works. And we have an error, illegal static declaration in inner class solution.result. Okay, so modifier static is only allowed in constant variable declaration. Okay, so this is a minor problem. So let's move this out from the result class. We have the result class, that is the closing curly brackets is containing the public static integer of the get node. So let's place this outside of the implementation. Let's select this, and then we use the alt and down arrow button to move this by 1, and then we place the get node function outside of the result class. So let's run this out to see if it works. Okay, so let's submit this. Okay, so that's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section. Or if you have any better solutions regarding this challenge, tell us what you think in the comment section. I hope you have a great day. Thank you for watching the video, and I will see you in the next video. Goodbye.